In this video, let's talk about conservation of charges. Okay, there are two types of materials or objects. The first one is charge, and the second one is neutral. Let's say in an object there are 100 protons and 100 electrons. Protons are positively charged and electrons are negatively charged. So the total charge of this object will be, we have 100 protons and we have 100 electrons. So the total charge will be 100 minus 100, 0. That means this object is neutral. There is no charge. Let's consider a different material or an object. In this object, we have 100 protons again, but this time we have only 90 electrons. How do you find the total charge? 100 positive charges, so plus 100, and 90 negative charges, so minus 90. So the answer is plus 10. This object is charged and it has 10 extra protons in it. So how do you find the charge of this object? We know it is charged, right? So how do you find the charge of an object? There is an equation for that. Q, the net charge of an object, equals difference in number of protons and electrons times E, where E is a constant, 1.6 into 10 to the power of minus 19 coulomb. Charge of an electron, charge of a single electron is minus E. E is positive, 1.6 into 10 to the power of minus 19 coulomb, capital C. Charge of an electron is minus E, so put a negative sign, minus 1.6 times 10 to the power of minus 19 coulomb. And charge of a single proton is plus E, plus 1.6 times 10 to the power of minus 19 coulombs. Okay, let's get back to this problem. We have 100 protons and 90 electrons. So the total charge Q equals 100 minus 90 times E is 1.6 times 10 to the power of minus 19. 100 minus 90 is 10. 10 times 1.6 times 10 to the power of minus 19, which is 1.6 times 10 to the power of minus 18 coulombs. That is the total charge of this object. Now we can shorten this equation by replacing Np minus Ne. So this equation will be Q equals Ne, where small n is number of protons minus number of electrons, and E is a constant, 1.6 times 10 to the power of minus 19 coulomb. Let's do another one. So in this object, we have, let's say, 10 to the power of 6 protons and 10 to the power of 8 electrons. So how do you find the total charge of this object? Equation is Q equals Ne, where N is number of protons minus number of electrons. So number of protons is 10 to the power of 6. Number of electrons is 10 to the power of 8. So the difference will be minus 9.9 times 10 to the power of 7. Let's substitute back in our main equation. Q equals small n is minus 9.9 times 10 to the power of 7 times E is 1.6 times 10 to the power of minus 19 coulomb. The answer is minus 1.59 times 10 to the power of minus 11 coulombs. That is the total charge of this object. Let's talk about conservation of charge. Conservation of charge. The total electric charge of an isolated system is conserved. What does that mean? Let's say we have two objects. Object number 1 and object number 2. And let's say in the first object we have 10 protons and 10 electrons. In the second object we have 5 protons and 5 electrons. Both of them are neutral because their number of protons and electrons are equal. If you find small n, you will get np minus n, ne, 10 minus 10 is 0. So total charge q equals 0 times e, which is 0. So these are neutral objects. Now if you add the total number of protons in the system, you will get 10 plus 5 is 15 protons, total 15 protons, and 10 plus 5, 15 electrons. Somehow I transferred 3 electrons from the first object to the second object. I have transferred 3 electrons. So second object has 5 protons and 3 extra electrons, so 8 electrons. In the first object, 10 protons, it has lost 3 electrons, so 7 electrons. Now if you find the total number of protons, 10 plus 5 remains the same, 15 protons. What about electrons? 7 plus 8, again 15 electrons. The total charge remains the same. So let's solve a problem. A blue ball, which initially has a charge of plus 6.4 times 10 to the minus 8 coulomb, touches a neutral red ball. After the balls are separated, the red ball has a charge of plus 2.6 times 10 to the minus 8 coulomb. What is the charge of the charge on the blue ball? You have two charged balls. First one is a blue ball, and the second one is a red ball. Okay, the initial charge on the blue ball is 6.4 times 10 to the minus 8 coulomb. So initial charge, this is the initial case. Initial case. Total charge on the blue ball, QB, equals plus 6.4 times 10 to the minus 8 coulomb. What about the charge on the red ball? It's a neutral ball. So charge on the red ball initially has no charge, 0. If you make contact between these balls, there would occur charge transfer. So let's say we are touching the blue ball, the red ball. So charge transfer would occur. And the final case, the red ball has a charge of 2.6 times 10 to the minus 8 coulomb. What is the charge on the blue ball? Final case, we don't know about the charge on the blue ball, but the red ball has been charged because of that contact. And the charge on the red ball is plus 2.6 times 10 to the minus 8 coulombs. We need to find the charge on the blue ball, QB. The final charge on the blue ball. Okay, we're going to apply conservation law here. The total charge remains a constant. So in the first case, we're going to find the total charge. Total charge will be QB plus QR, which is equal to 6.4 times 10 to the power 8 minus 8 plus 0, which is 6.4 times 10 to the power minus 8. So this should remain the same, coulomb. Yeah, this should remain the same, 6.4 times 10 to the power minus 8 coulomb. That is the conservation of charge. Okay. So we are going to calculate the total charge in the second case. We know the answer. If we add these two charges, we should get the same number, 6.4 times 10 to the power minus 8. All right. But we don't know the charge on the blue ball, so I'm going to keep it QB. We don't know that. Plus, charge on the red ball is 2.6 times 10 to the power minus 8. Equals the same answer, should be the same. That's the conservation of charge. Now to find QB, take 2.6 times 10 to the power minus 8 to the other side. So 6.4 times 10 to the power of minus 8 minus 2.6 times 10 to the power of minus 8. 3.8 times 10 to the power of minus 8 coulombs. A piece of metal with a charge of minus 6.4 coulomb contains 2 times 10 to the power of 20 protons. What is the number of electrons in this piece? The equation to find total charge is Q equals N times E, where N is number of protons minus number of electrons. In this question, we are given the number of protons and we need to find the number of electrons. So I'm going to replace small n with Np minus Ne. Q equals, I'm replacing small n with number of protons minus number of electrons times E. And what is E? E is a constant, 1.6 times 10 to the power of minus 19 coulomb. It's positive 1.6 times 10 to the power of minus 19 coulomb. A piece of metal with a charge of minus 6.4 coulomb, that is the total charge. So minus 6.4 equals number of protons is 2 times 10 to the power of 20 minus number of electrons times E is 1.6 times 10 to the power of minus 19 coulomb. We need to find Ne, so I'm going to remove 1.6 times 10 to the power of minus 19 from the right side. So N 2 times 10 to the power of 20 minus Ne equals minus 6.4 over 1.6 times 10 to the power of minus 19. So Ne equals 2 times 10 to the power of 20 plus 6.4 over 1.6 times 10 to the power of minus 19. Number of electrons, 2.4 times 10 to the power of 20. This object has a negative charge. That means it has more number of electrons than protons. It has 2 times 10 to the power of 20 protons. And we got the answer. It's 2.4 times 10 to the power of 20 electrons. That makes sense. 2.4 times 10 to the power of 20 is greater than 2 times 10 to the power of 20. A neutral conducting sphere has been charged with a charge of 8.32 microcoulomb. Which of the following is correct about the sphere? Initially, the sphere was neutral, there was no charge, and it has been charged with a charge of 8.32 microcoulomb, positive 8.32 microcoulombs. Only electrons can move between the atoms. So the first two answers are wrong. Gained 5.2 times 10 to the power of 13 protons and gained 8.32 times 10 to the power of 6 protons, because protons cannot move between the atoms. So now our answer should be either C or D. Let's find out. So the equation is Q equals Ne. Q is 8.32 times 10 to the power minus 6. Micro is 10 to the power minus 6. 10 to the power minus 6 coulombs equals N times E is 1.6 times 10 to the power minus 19. Let's find N. N is the number of extra protons or extra electrons in a charged object. So N equals 8.32 times 10 to the power minus 6 over 1.6 times 10 to the power minus 19. Answer is 5.2 times 10 to the power of 13. The total charge of our object is positive 8.32 microcoulomb. So it has lost some electrons. That's for sure. If this was negative, the answer would have been gained some electrons. And we just found how many? N equals 5.2 times 10 to the power of 13, right? Lost, this is for positive and this is for negative net charge. Because our answer is positive, we have lost some electrons, or we have lost 5.2 times 10 to the power of 13 electrons. The answer is D. Example 1.1, net charge. Problem: if we wanted a block of iron of mass 3.25 kilogram to acquire a positive charge of 0.1 coulomb, what fraction of electrons would we have to remove? Mass of iron given in the question is 3.25 kilograms and the charge Q is 0.1 coulomb. And we need to find the fraction of electrons that we have to remove for this iron block to obtain 0.1 coulomb. It has positive charge, that means we have to remove some electrons. And what fraction of electrons we have to remove? That's the question. To solve this problem, we need to know the atomic number of iron. It's 58. All right. So what fraction of electrons would we have to remove? So what we have to find is number of electrons lost, that is N delta E divided by total number of electrons. Let's say NT, where N delta E is number of lost electrons divided by what is NT? NT is the total number of electrons, or let's call it NE, it's better. Total number of electrons. Total number of electrons. This is what we have to find. This is NE. N delta E over NE. Okay, let's find N delta E first. To find the number of electrons lost. Yeah. For that, it's very simple. Q equals NE. We have total charge. So it's easy to find small n. Q is 0.1 coulomb. N is unknown. E is 1.6 times 10 to the power minus 19. So N is equal to 0.1 over 1.6 times 10 to the power minus 19. 6.25 times 10 to the power 17. This means to obtain a charge of 0.1 coulomb, we have removed 6.25 times 10 to the power 17 electrons from this iron block. Okay, now let's find the total number of electrons in 3.25 kilograms of iron block. Let's find the number of moles. Number of moles equals mass, total mass in grams, not in kilograms. Kilogram is the SI unit, but to find the number of moles we have to substitute mass in grams divided by atomic mass in grams. Gram atomic mass. Atomic mass of iron is 56, and atomic number of iron is 26. Atomic number is the number of electrons or number of protons. Atomic mass is the number of electrons plus number of protons. Let's find number of moles. Mass in grams. 3.25 kilograms. Convert that into grams. 3.25 times 10 to the power 3. Kilo is 10 to the power 3. Gram atomic mass. Atomic mass is 56. So gram atomic mass will be 56 grams. 58 moles. We have 58 moles in 3.25 kilograms of iron block. What do you mean by mole? 1 mole. Mole is just a number. 1 mole is 6.022 times 10 to the power 23. Avogadro number. We call this number as 1 mole. So 58 moles will be 58 times replace moles with this number. So total number of iron atoms in 3.25 kilograms of iron block will be 58. There are 58 moles, and 1 mole is 6.022 times 10 to the power of 23. So total number of iron atoms will be 58 times 6.022 times 10 to the power of 23. 3.49 times 10 to the power of 25 iron atoms. In 3.25 kilograms, we have 3.49 times 10 to the power of 25 iron atoms. We need to find the total number of electrons, not the total number of atoms. We have the atomic number, and atomic number means number of protons or number of electrons. In one iron atom, there are 26 electrons, and we have 3.49 times 10 to the power of 25 iron atoms. So total number of electrons will be number of iron atoms 3.49 times 10 to the power of 25 times there are 26 electrons in one iron atom. So total number of electrons will be 3.49 times 10 to the power of 25 multiplied by 26. 9.08687 times 10 to the power of 26. In 3.25 kilograms of iron block, there are 9.087 times 10 to the power of 26 electrons. That is Ne. 9.0, round it off to 9.09 times 10 to the power of 26, and number of electrons lost is 6.25 times 10 to the power of 17. Number of electrons lost, N delta E, is 6.25 times 10 to the power of 17. Fraction of electrons to remove equals number of electrons we have to remove over total number of electrons. 6.25 times 10 to the power of 17 over 9.09 times 10 to the power of 26. Answer is 6.87 times 10 to the power of minus 10. That's a fraction. Yeah, 6.87 times 10 to the power of minus 10.